So, hi, my name is Peter. Um, I'm going to tell a story. And by telling a story, hopefully, it's going to inspire some sort of cool features of as we go along. And the story is about how I migrated one system that used MySQL to Postgres and the features that came out of that. So this is as everyone always has, this kind of a selfish slide to start up with, and this is mine. And I just wanted to point out a couple of things. I work at Mozilla, and I'm a web developer, so I'm not a DBA. I feel a little bit like an alien in this crowd. But I know my way around Python, and I have been using both MySQL and Postgres for a very long time. But still only as a developer. And the perspective of all of this is basically as a developer, which I think you'll just see, you'll permeate through it. So the story is split into two parts. So hence the split personality. First part is about getting away from MySQL. Sorry, that sounded like a charged way of saying it, but upgrading to Postgres, that's equally charged, but changing from one database to another. And the other side of this is the benefit of it, like the why. And that's the full text indexing and search. So why bother migrating? You've got two perfectly good working cars. In this example, I'm trying to make a point. Here you got your Postgres Model X, Model SQL, and you got a MyCivic. And I have a Civic, so that's why I dare to make fun of the Honda Civic. Yeah, they have similarities. They have wheels, they have engines, they have indicators, but one of them is electric, and it's awesome. And both take you from point A to B, but they do so differently. And why not enjoy the ride whilst you're going to point B? So before I talk about the migration piece, let's diverge a little bit and talk about Django. I don't want to assume that everyone knows Django. I'm sure everyone knows of it and have heard of it, and it's a Python thing. And ultimately, it has an ORM. So when you enter the land of Django, you basically stop writing SQL to some degree, and you can start using the ORM. And so Dimitri touched on this in his presentation, that you should know your data, and if you can push with the right functions, you can get some amazing features out. And the alternative, kind of the flip side to Dimitri's point, is that you can take that dumb data and expand on it. For example, instead of using ranges, you could have a batch script that explodes the ranges and inserts them in a kind of a dumb way. So there's a counterbalance between using an ORM and not. And I think there's a certain benefit to using an ORM in that you can keep things in one land and keep it simple. But there's definitely times where you need to go into the deeper depths of actually knowing your SQL. We'll get to that actually. So a key feature, I think, of the Django ORM is that it's kind of so good that people don't bother using the CLI of the database because they can use the ORM for almost everything. A long time ago, people were saying that the ORM, it's cute, but it doesn't do what I need to do, the type of joins I need to do. So I'll use SQL Alchemy, or I'll fall back to. A lot of that has changed. It's not 100%. It will never be as good as doing it in SQL, but it's got some pretty cool features. And it takes care of migrations. Migrations, in this case, being the alter table stuff, not necessarily moving from one system to another. All right, so now we're going to go through this step-by-step story about the migration. The first thing to consider is you need to stop the site at some point. You need to kill it and run the migration from the MySQL to Postgres and then start it up again. You could potentially rethink that, go into read-only mode. All of this basically depends on how much downtime you can have. Before you do any migration, obviously you run this new code, the Postgres-based code, and you run it locally, and you write unit tests for it, and so on. And so it should be, everything should be ready to go. The only thing is missing is basically the data in the right place. So these are the commands. First one is obvious for everyone. And then the second one is, it's a minutiae detail, but I just wanted to show how simple it is to switch from MySQL to Postgres as far as Django is concerned. And the last two commands here are basically, a key thing here is that, so we have the data with tables in MySQL, and we now want to have it in Postgres. And the first thing you do is that you let Django, and the Django ORM, create those tables. And that's what those commands do, syncdb and migrate. The migrate word is, again, it's a bit confusing, but what those things do is they put the data, they put the tables in place, and it actually puts all the indexes in place too. And there's a word here, AirMozilla. That just happens to be the project. And that's the name of that database table. That was the project that I worked on. AirMozilla is a Mozilla website that wants to be YouTube. So it's a video archiving, live broadcasting type of site. And it started in MySQL, and thanks to this, it's now a Postgres-based. So this is all you need to do to them Django changes. You just basically change the engine from one engine to another. And as you do that, you might need to update your database. In this case, the database name is probably the same, but you might have a different user, password, and host, and so on. And that's basically all you need to do to switch database. Yes?
Is this after all the commands?
No. This is before. So you change Django's settings so that after you're right. What you need to change this, you change the settings of Django first. So when you run these last commands to set up the tables, it now knows to speak Postgres and write the appropriate create table commands for Postgres. And at this point, the site is still running. You haven't stopped it, but that's because it's always already loaded in the settings, and it's booted that into memory, so it doesn't reload the settings. Hypothetically, we can assume that the site is down now. Actually, we'll get to that later. So now, here's the trick. The tool that I used in this story is called PyMySQL to PostgreSQL. And it's pretty plain and simple. It's just a little Python script. I think it's basically one file. And the way it works is that you install it into your system, you run it once, where it creates a YAML file, which you edit. And this is the YAML file. You simply fill in those details like the host name, username, password, etc. And then you're ready to go. So now is the actual point where you need to flick that switch to switch off the site, because if people start writing into your database after you have actually executed the migration, you're losing data. So hard at the site or flick a switch so that it goes into some sort of read-only mode, which isn't easy to write. And then you run it. And that's the command. It reads in that YAML file, opens up a MySQL connection, opens up a Postgres connection, and just does a dumb copy of the data in. And so the PyMySQL to PostgreSQL is a little bit simplistic. It doesn't have the full data type support that you might desire. It's got a decent amount of them. But in my story, what I had to do was I had to do a manual conversion later, because all the timestamps became timestamps without time zones. And I want time zone. MySQL doesn't know what time zone is, so it couldn't have migrated then. So I wrote a simple little command like that, stored it in a SQL file, and once the Postgres database had been populated, I just executed this file against it, like so, and we're done. Now we can restart the server, and everything should be running in Postgres. Yay, party. So, a couple of more notes about this PyMySQL to PostgreSQL. key thing that it doesn't support is spatial data. So if you have that, there you're in for a surprise. The code hasn't been touched much for years, but I don't care. Like, it seemed to have worked. It did in my case. Yeah. And some notes about how long this took. So when I ran it against my core project, the Air Mozilla project, I forgot to take notes on how long it took. So I took another MySQL database, one with 4.5 million rows, went through basically these notes that I have for my slides, did it all over again, as if it was this next project's turn. But this time I managed to actually measure it on my laptop, and it took 3 minutes to run the full migration. So that's if you use this tool for a 4.5 million rows table, that's roughly what you would have to look at in terms of downtime. But then I meet Dimitri yesterday, who tells me about PG Loader. And it's the tool that I guess I was looking for that didn't exist at the time. And I think it existed, right? But it didn't have the full MySQL support. It's kind of weird to talk about a person who's sitting right there in front of me, but Dimitri and I, we tried to replicate this one more time, but for another project that also uses the Django ORM. And it didn't quite work because PG Loader assumes that it gets to do the database table creation too. And that could be a little bit of a predicament, because if you don't let Django and its ORM handle the creation of tables, as things are changing, it might say, I don't recognize these. Something must be altered or something. But I think we've established what needs to be done, and I think this is potentially the tool to use. Which brings us to the last 2 points. They're basically being the same thing. With PG Loader, we tried this from scratch for the same thing. Instead of 3 minutes, over 3 minutes, it's now 42 seconds. And I think the key here is that what PG Loader does is that it puts the data in first, and then it creates the indexes, so that it can batch create the indexes all in one go. And there's some internal optimizations that Postgres can take advantage of that makes this significantly faster. So what we're looking at is 42 seconds for 756 megabytes is a gig a minute. And I don't think that can get much faster, because data needs to be written It's not a matter of moving. It needs to be duplicated in pure I/O. So if you're lucky, you can use MySQL to PostgreSQL. Probably you won't be as lucky as I am. I don't know. Who knows? But the proper tool would be PG Loader. So why did we migrate? First of all, because, I don't know, I'm sure you've seen it 1,000 times. You've got people who are very, very passionate about Postgres who have used both, but you never have people who are passionate about MySQL who have used both. And I'm one of those thousands of people, I believe. And I ask around colleagues, everyone seems to prefers PostgreSQL. No one ever says the opposite. So it's got cool features. The features that matter to me in this story was the ability to have milliseconds, which can be very, very crucial, especially for integration tests, because you're writing things very, very rapidly without any realistic kind of network latency. And then the ordering of timestamps might actually matter. You can do massive alter tables without worrying about breaking things halfway. You got solid foreign key references that are good. You don't have that scary Oracle licensing feeling that you get with MySQL. And I think maybe the most important feature and the reason is that you can do Control-C when you're in the PSQL CLI. I don't know if you remember or have used the MySQL. If you do that, you exit. So if you're halfway finishing a SQL command, you hit Control-C, it exits, and now you need typing your password to get back into the CLI. It's annoying. But the most important feature in this story, to be serious, is the full text indexing and searching. So how would you do full text indexing in MySQL? There might be some plugins. Last time I looked, these looked old. I talked to I think she's a committer to MySQL, Sherry Cabral, who works for Mozilla. And I tried to get some advice about how to do it. So I went pretty deep on this to see if I could do it in MySQL, and I just couldn't. And it kind of pleased me because this gives me an excuse. Say, hey, I need Postgres now. You got to get on board with me. I'll write all the code, but you need to be there and help me migrate and support it. In MySQL, this is how you do it. You do a match operator. You type in the title, sorry, the columns that you want to match against. And what it does, it basically looks through those column and description. It looks through every word and just strips away stop words, does a little bit of basic tokenization, so full stops, quotation marks, brackets and stuff. And that's it. And it just matches, basic, that's what databases do. And a key thing here is to notice that this actually is faster than Postgres. And maybe we'll look into the details of that later. But I think the more you think about it, there's only so much a computer can do. The less you do, the faster it is. And the more features, the longer times. I don't think it's a matter of certain algorithms being better or worse. It's just comparing apples and oranges. But the key difference here is that MySQL does not support stemming. And that is not a small thing. I know I've seen the MySQL bug. It's been filed a long time ago, and it still hasn't had much movement. Last time I looked was a couple of months, but who knows? It could have changed since I migrated, but I don't think so. I haven't heard anything. So I wrote a little script that's quite highly optimized. It's using an open connection, 2 cases of using the DB API in Python, and I run a bunch of words searches. These are indexed, by the way. These are indexed in both MySQL and Postgres. In MySQL, you can't do it without indexing, by the way. And I run these words against a pretty big but still medium-sized table. It's got lots of text fields. And I run them over and over so that the cache is warm. And as you can see, the list of words are a mixture of nouns and some proper nouns and some non-nouns that can be conjugated. And the key difference here is that Postgres takes a longer time to find all of those. But out of a 400,000 row table, it found 6,000 words in 17 milliseconds. And that's fast. That's pretty damn fast. So it pulls out a lot of data in a very intelligent way in a very small amount of time. So I don't sweat so much over the difference between MySQL and Postgres here in terms of time. And the key difference here is that Postgres finds more, which takes us to the next slide. You notice that it finds 6,257 items in Postgres and only 4,658 in MySQL. So stemming, what's the big deal about it? So stemming is, first of all, it's dependent on the language. And our site is written, the content is in English. The code is in, obviously, English too, but and that's a very key thing to take that stance and be aware of that because it changes everything. The next bullet point here is just a little refresh as to what stemming is. It's finding in a natural language way the base of a word so that they can be indexed as the base, and then you can do faster comparisons. And it's smart enough to be able to tell the argue and argued is the same word. It's I think it's arg or something like that as a stem. But it doesn't do so with other things that are genuinely in the spoken English language, different things. An argument is not the same as arguing. So when you do search these days, and I've done it on quite a few sites, you will always fail. And that's because Google is always better. And no matter how much features you put in, people have got so used to Google that they almost autocomplete what they were thinking, which is amazing. You're thinking about a restaurant, so you start typing LA and it finds Latifa the restaurant or something like that. And people sort of just expect that on your sites that you build too. And that's why stemming is important. You can't just, I remember Google saying, we used to be expected to find what people search for. Now we're expected to find the things that people think of. And I don't know, you've got to take some of that on board and try to please the user and their way of thinking more. And stemming is a key to this, to be able to achieve this. So by the way, the reason why we saw so many more results in Postgres is because of stemming. And I'm going to jump back one slide. None of these words have hyphenation in them. So if you add the same benchmark and now do hyphenation, it kind of, this sounds like I'm just laying in on MySQL, but this kind of blows up in the case of MySQL. If you search for something like add-on, which is a word, I don't know if you find it in English dictionary, but add-on is a word, and so is email, and pop-up, and tic-tac-toe. What MySQL does, if you search for an add-on, add-on is a bad example. If you search for front-facing, MySQL will find everything that matches the word front and everything that matches the word facing. And that's not correct. That is just not true. Front-facing is a word. It's actually a very realistic thing that you want to find, because you might be, you're probably going to be typing in hyphenation words into your searches. So now we see basically that if you were to do these searches, MySQL fails miserably by finding just too much junk. And it takes a lot longer to return more rows. I guess this alludes to that MySQL isn't particularly faster. It just, on the previous slide I said it was faster, but if it just finds less things to return, it takes shorter time to return the I/O. So now we're taking a little bit of a tangent, and now I'm going to sort of motivate why I did all the migration and how you can build an awesome search. Oh yeah. If you were looking for Waldo, he's right there. So how do you build a great search? I have a traditional data application with, you've got events, and events have a video, and they have metadata, and there's comments about them, and there's statistics about them, and there's audit trails left, right, and center. And I want to make it so that you can just type what you were thinking and find that way. So the key requirement here is I need to be able to filter the data on other things. For example, data that is you should be seeing or not seeing no matter what you type in for a search. So that's a key. I must be able to do that kind of filtering. I want to search on the title first, because the title is probably more important than the summary or the description of the model. And I want to be able to rank the results, so it's not good enough to just find the items that match. You want to rank in a very humanly intelligent way, and that is to rank differently on the title as you rank to, say, the description of the event or the date. Another key thing is the try and search, or back up with an or search. And that is, if you search on a multi-word thing, you might not find anything, but that's because it was never entered with both words. So if you were looking for Catherine Devlin, but there was an event that didn't mention her full name, it just mentioned Catherine. So if someone searches for Catherine Devlin, it doesn't find anything, but it should go back and try again and see, is there anything where Catherine or Devlin? And we want to have highlights on our search results. So I'm going to go through the basic steps of how to get this done, and I'm going to go through it using the ORM rather than SQL. And that's because it would be, I think it's pure, and it's quite readable, and it hides a lot of the mundane doings of the SQL, and you can actually see that the SQL that matters later. So the example here is very clear that there's a bunch of hard metadata fields that you want to filter on. For example, approved. In our case, it's actually more complicated than that because that's a many-to-many relationship. But the next line has an example of a many-to-many filtering, and they can build up. And I think this is somewhat realistic to our application. We have maybe one or two more that matters, and that's your basic stuff. That's the stuff that comes back after you've done a search. So far, it doesn't take your search term into account, but this is the search results we're looking at here. And yeah, if I were to print this as a query, it gets kind of messy. So therefore, I think it's easier to do it in a Pythonistic way. So now we add the search magic, and you get the search query in from the request, and you add your pure SQL into that ORM snippet. And this is one of those cases where you will never have a perfect abstraction in any ORM. Sooner or later, you will need to inject some specific SQL, and this is one of those cases. So here we're using the at operator to compare one of these full text vectors, and to do one on the fly based on the parameters that are coming in, which is in this case the terms. And I'm using a function called plain to TS query. That means it's easier to explain this with the opposite, and that is the to TS query function allows you to use ampersands and pipe signs to do or and and searches. But a human, God bless her, doesn't know how to type those in, so we can't expect people to type in ampersands and pipe signs. Like Google don't expect that either. And so this is how you combine an ORM, which is neat and kind of pure and simple, with some really hardcore SQL. I don't know if it's that hardcore, but you get full power here at least. And it, by the way, the ORM will take care of inserting the actual values, so you don't have to worry about potential SQL injections there. Now we add ranking. So the way you do that is you let it do its select star, but you add extra. So it's basically kind of similar to select star, comma, and then you add your own. And you use a function called tsRankCD. And you basically reapply the same search that you did, and this gives you a floating point number. So you have, you have your select star, and you have some extra floating point numbers. And the key functionality here is the last line. So the way I prefer to order it is to only first show those that it matches in the title. And it is rarer to find something matching in the title than to have something matched in the description. Or in our case, we have both a description and a short description. It depends on how you're navigating the site. And then the number 2 here is the start time. So freshness is almost more important than it being matched somewhere in the document. But title is pretty darn important. And there's nobody really knows other than the few people at Google, but there are rumors that when Google does their order by, they don't do it this simply, but they have over 100 of these little signals, they call them, reasons for showing something higher than another thing. And a lot of people think that PageRank that's it. They just use PageRank to sort. Now that's one of 100. So there's 99 other reasons why one URL should come higher than the other. And I'm cheating a little bit because if you want to use this functionality on the ORM where you do an extra, you actually have to do them all in one, but I'm splitting it up. I'm going back one slide. I'm doing it twice. So you actually have to do it all in one, basically in one slide. But and this TS headline is an HTML-aware little function that takes a piece of text, removes any unsafe HTML characters from it, and reinserts a tag to highlight the word that it found. Now the OR search is only something you can really do if they typed in 2 words in their search, or 3 words, or anything greater than 1. So I wrote a little wrapper around this, and the way I do it was I let it do a count first on how many results I got back, and if that count is 0, and the thing you search for contains a space, and there's no hacky ampersands or pipe signs in there, then I can dare to convert the search term into a proper search term with using the pipe sign. So I basically look if there's a space, and if there is, I split it up by spaces and put a little pipe sign in between, and now reapply the same search before, but using a different function, in this case that 2ts query. And you need to be careful here so that you don't allow any operators in, because you can't really trust that people have typed what you do. Turns out that this is actually a lot easier than you think. There are some potential hack attempts on the server, but it never leaks any data. The worst thing that can happen is that you get some sort of syntax error. And then the way you display it is you loop over the results, and because you added this extra highlight function, you now get that associated in the result set, and you can display it, and it has already escaped anything that needs to be escaped, so you don't have to worry about escaping in your HTML, as per this example. You might do it in JSON or some other way, but it's just a little show of how to do that. And the benchmarks I had, it was actually done on a different table. A cool thing about Postgres is when you use full text indexing, you don't actually need to have indexes on them. In a sense, that's weird to say because you do, because it makes it a million times faster. But if you're concerned about having too much indexing because it uses up too much disk, and there's something you full index search on very rarely, you can leave out the index. But this is the syntax for creating indexes using the gin function. And there's a little trick in it. The comment is hard to read here, but if you want to do a full text index on a text field or varchar field that can have nulls in them, you need to be a little bit careful. I think this is only really applicable when you're trying to combine multiple varchars into one, or text fields. So the way I'm doing it in my application is that I let the query run once with a count. And from that I can benefit from two things. I can say if the count was 0, I might want to try again slightly differently. I can also keep this count to show in the top of the result page to say, hey, there were 1,388 items found. Here are the first 10, or your first homepage. So that's kind of useful. But you could potentially do this in one query, or if you feel very inclined to do so. And I found that it's so fast that it doesn't really matter, so it's okay to do it twice. I mentioned earlier here about the plain 2ts query and the 2ts query. You have to be a little bit careful to what you put into the 2ts query, because it assumes that you know what you're doing when you're typing in, but this is user data, so you can never really assume anything. Another option which I attempted a little bit was my table in this case has a bunch of fields such as title, short description, description, but it also has a bunch of other things that contains humanly typed in English stuff, such as tags or channels or other things. And what you could do is potentially just put all of that into one column and maybe have a trigger function, or if you do the equivalent of a trigger function in your high-level application in Django. So you just basically concatenate everything into one massive text field. You have the advantage then that you just need to do a search on one single column, and you can just bombard it, because if you want to do a full text index search on, say, 6 columns, it might get very, very expensive. The disadvantage with having just one big fat column is that if you're going to highlight some of the results, you're potentially highlighting concatenated data. So you might have a normal English sentence followed by a new line character and some stuff coming in from another field, and it doesn't feel right to highlight those results. And also, most importantly, it's harder to do ranking. So what I did in my example was that I prioritized matches against the title compared to matches on the description. Postgres has support for synonyms. I haven't used it in this application. I only know of it from reading the documentation, but basically what you do is you write a little file. It's like, I don't know, synonyms dot, and then there's a certain file extension, and you write down words, one word and another word, of what might be a synonym, because there's no way the computer might know what a synonym is. So if you have picture, photo, that's one, and you might know this. You write those down in a file, but this has to be humanly maintained. It is possible to do some spell correction. It's not super trivial, and I wasn't super impressed with what I read on it. I haven't tried it out. There are other solutions around spell correction, such as maintaining a list of all the words used elsewhere, and then you can use that to build up a edit distance and compare what you typed in on a search with what's in this index, and you can convert those on the fly. I think it's a little bit out of scope for this context, but it is doable. So I'm very fast here, but that was it. I'm very pleased with how easy this was. I'm lucky in that the application was written very much with the abstraction the Django ORM in mind, because it made it doable. I think now with PG Loader, if you have a little bit more of a complex data, a MySQL database, you have a little bit more power there. That program, it needs a little bit of work in some of the rough areas, but it's getting there. And I think my number 2 point here is probably the most important thing about all of this. And that is, how would you do this if you didn't have full text indexing and searching in Postgres? It's not an unusual case to have data containing lots of English information. And by English, I mean human language. It doesn't have to be English. It could be French, Spanish, you name it. It's not unusual. The only other way to mix these two, because the filtering is important and the matching is important, is, I don't know, you can go the MySQL way and say, hey, I can't do that search very well. We're just going to have to match specifically on the words you typed in. No stemming, just go away. Or what you could potentially do if you were stuck with MySQL was to go through every word in the database and explode on the words that have a stem using some other third-party tool, say like NLTK in Python. So you could effectively like pretend that the title is what it was originally, but every word that can be stemmed changed to all the variants. Very complicated. Another approach, I guess, would be using Elasticsearch, which is based on Lucene, which is a very good natural language indexing tool. And colleagues of mine are using this, and I think they've achieved something really cool, but they had to go through hell back and forth. First thing, what you do is you have your Postgres database. Actually, they use MySQL, so maybe that's why. You have to go through your data, and you have to constantly send some of your data to your Elasticsearch, because it's a different database. For example, you need to write some code that on every save, it ships a version over to Elasticsearch and say, hey, I am document ID 3356. Here's the new data. And you send that over, and then when you do your search, you ask Elasticsearch, hey, can you search on the word argument or arguments? And it comes back with all the IDs, and then you go back to your database, your relational database, taking all these IDs, going through them one by one, and then now you apply your filtering. It gets quite messy. And there's a sort of solution to that too, and I've been there. I don't know if any of you have used Zope, but they had this going back in, say, 2000 they had this. It was called the Z catalog, and it was a database sitting alongside the main database that just did full text indexing, and it did other things too. And effectively works that you do a search against that thing, and it gives you these sort of ghost objects back that have an ID, and you can use ID to ask your other database for the full object. But sooner or later, you realize, but actually, we need to do the search on free text and only show those that are published, or only show those where the author equals Peter. And now, oh shit, now we need to also index those over in the other database, in the catalog. And yeah, before you know it, you have a very, very complicated solution. It's doable, but it is quite complicated. And I think, and this is maybe the whole win of all of this, this was not complicated. You can stay so close to the truth, where you have your main database that do a very straightforward select statement. Straightforward as in, it's just a couple of little joins to do, you know, where published equals true, or, you know, where author equals this, or something like that. And you combine that with this super powerful ability to search by text. And so my last 2 points on this slide coincide together. As I'm preparing this, I'm realizing the depth of the full text indexing in Postgres. And you realize, shit, there's a lot of features there, and I haven't mentioned half of them. And I guess it makes me feel like, oh no, I don't know what I'm talking about. I'm not an expert. This presentation from 2 years ago, I can't remember the name of the author of those slides, but that's the place to go to, and that mentions everything you need to know about full text indexing. But I think I've proven that I can accomplish quite a useful application with full text indexing search using just those basic commands, as we saw, with a little index. And those are easy enough to copy and paste. They're that simple. And that is all, ladies and gentlemen. I'd love to hear more from people who have solved similar situations and their war stories. Okay, that's all. Do we have any straggling questions? No. Well, thank you anyway.